video, I simply want to do a little overview for Module 8 on the Lewis dot diagrams, the Lewis structures, Lewis dot structures. They're all the same. Okay, so I want to start with carbon tetrachloride. It's a covalent molecule. So carbon is in group 4. It has 4 valence electrons. Chlorine is in group 7. It has 7 valence electrons. So for carbon, I have carbon and I drew 4 dots for each valence electrons. For chlorine, I drew 7. Now in your book, Dr. Wiley talks about the Octet Rule. That means, with a couple exceptions, hydrogen, helium, okay, with a couple exceptions, they're trying to have a total or complete 8. So if we look at it, look at chlorine. It now has 8 valence electrons, 2, 4, 6, 8. This chlorine, 2, 4, 6, 8. This chlorine also 8, 8. And look at carbon, 8, 2, 4, 6, 8. Now, carbon and chlorine are sharing these electrons. But by sharing these electrons, both chlorine and carbon satisfy the octet rule. They have a total of 8 electrons. Now we can also write it carbon tetrachloride, CCl4, like this. So the line is a single bond. Now, I can look at oxygen, okay? Each oxygen is in group 6. That means it has 6 valence electrons. So I put 6 dots, okay? 2, 4, 6. And we look at this oxygen, 2, 4, 6. Now, in order to satisfy the octet rule, that means each of these oxygens want to have a total of 8. If the oxygens share 2 pairs, so this oxygen, 2, 4, 6, 8, and this oxygen, 2, 4, 6, 8. By sharing these 2 pairs, they satisfy the octet rule for both oxygens. Because they're sharing 2 pairs of electrons, I can represent it with 2 lines. Now, let's look at hydrogen. It's in group 1. It's actually not, remember though, this is not an alkali metal. Okay, but it has 1 valence electron. Okay, so each hydrogen has 1 electron. And remember, they're in the first energy level. They're only in the s orbital, and it's full when it has 2. The first energy level only has s. When it has 2 electrons, it is full. Each hydrogen has 1 electron. When they share it, the energy level is full. The s now has 2. It's complete. 1s, 2 is complete. We can represent it with 1 line for 1 pair, and that represents a single bond. Now let's look at nitrogen. It's in group 5. That means nitrogen has 5 valence electrons. So let's look at it. So I put these in different colors so it'd be easier to see. This nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. So does this. 1, 2, 3, 4, 5. And when they share a total of 3 pair, 2, 4, 6, 8, 2, 4, 6, 8. Each one satisfies the octet rule, and they have 8. And we can write this then, of course, as a triple bond, and this would be O2, H2, N2, and remember these are all diatomic molecules. These molecules, when they're by themselves, travel in pairs. And here's why. By traveling in pairs, they each satisfy the octet rule. Or in this case, it's not the octet rule, it's just a pair. But they satisfy it. These diatomic molecules, oxygen, hydrogen, nitrogen, okay, travel in pairs, and oxygen has a double bond, hydrogen has a single, and nitrogen has a triple. That's it. Now, next one is polyatomic ions.
Are you done for this one?
Yes.